Hello, students. Happy Sunday. I hope
Happy Halloween!
Oh my god. Hey, is that fried chicken?
Yes.
Can I have it?
Sure.
I'm taking all of this.
No.
I hope you guys had a good Halloween. It was an awesome football game too. If you saw it, man, it was crazy. Um, This is a video to show you just how to go through your data that you got from the videos you made in the lab, and put that into Logger Pro, and then get the information using Logger Pro and put that into your document that you'll submit. So this is your Logger Pro screen when you first open it. To put in your video, go to Insert, go down to Movie, and then depending on where you have it saved, it'll be over in one of these places. Maybe you have it on a flash drive because you got it from your friends in the lab, or maybe you were actually the person recording it with your laptop, and if that's the case, then it will be underneath Pictures and Camera Roll. So this one, I have a sample video right here. I recorded this in the classroom. There's my sample video comes up. If you wait a moment or so, it'll get most of the video loaded. I think it's loaded there. And I'm going to size it down just a bit to make it easier to use. Bring it over here to the center of the screen. It'll probably look black to begin with, just a plain blank screen or black screen. That just means it hasn't really completely loaded. First thing I want to do is bring up my toolbar so I have all my options over here on the right hand side. And I'm going to play the video until there it is. The video actually has some sound to go with it. How wonderful is that? I'm going to stop right about there. Looks like that's about where the person lets go. I'm going to use these buttons down here, go through the video frame by frame. This one goes backwards frame by frame, and this one goes forward frame by frame. So the person already let go of the car, so I'm going to back up the video frame by frame until the person holds on to it again. Okay, now I'm going to put in my X and Y axes first. So this is the one with the little green crosshairs right there. Since mine is going from right to left, I'm going to put it over here and spin it around. You don't have to do this. I just like to do this because that way I'm going to get a positive acceleration. If yours is going from left to right, then just put your X and Y axes in there somewhere. Make sure this line is parallel with the line, the ramps, the level of the ramp, or the surface of the ramp is what I should say, or the track is actually what I should say. But like I said, if yours is going from left to right, then just put your crosshairs over here. And if you don't spin around like that, that's totally fine. It just means you'll get a negative value for acceleration. There's nothing wrong with that. Okay, now I need my reference frame, or like a distance reference. So I'm going to click on the scale. It says set scale on your Logger Pro. I know that the car from this corner to this corner is exactly 17 centimeters. So I'm going to click on that corner and drag over to the other corner. That's exactly 17 centimeters. If I need it in meters, don't put this in centimeters. Make sure you put this in meters. So 17 centimeters would be 0.17 meters. There we go. Now I've got the X and Y axis and the scale or reference scale set. So now I'm ready to start clicking on the video where the car is. I'm going to grab that big red dot button. It's the second one down. And I'm going to arrow forward until at the moment when I see that person's hand let go of the car. Hand is coming away. Pretty much right there, the person has let go of the car. And now I'm going to start clicking on some sort of a point on the car. So I've got a big yellow dot on the car, so I'm going to click on the yellow dot. And every time I click on it, it puts a data point on my graph behind the video, and it advances the video by 1 frame. So I just keep on clicking there. The car doesn't move very much in the beginning. And now the car is starting to move. Don't worry about if your pointer moves up and down just a little bit, because we're not worried about the vertical axes. We just want the data from the horizontal motion. Horizontal. And as the time goes on, the car starts moving faster and faster, so you get to move through the video a little quicker. Also, this really needs to be done with a mouse. I mean, you could do this with a touchpad, but it's so much easier if you have a mouse attached to your laptop, just because it's much easier to point and click with a mouse than it is with a touchpad, considering how many times you have to point and click and point and click. Now, as soon as this person's hand comes down and touches the car, that's where I'm going to stop. And I think I can get one more. Yep. Okay, that was my last one I'm going to do, because now the person's hand is touching the car and it's not moving anymore. So I don't want to plot any of that, because I would be plotting no motion. So make sure you stop making points when the car stops moving. So I don't need the video anymore. So now I'm going to click on the graph behind the video, and I should see a nice parabola in it for the x distances. It shows right here my x in meters is the red dots, and my y is the blue dots. Well, I don't need the y, so I'm going to click over here on the y vertical axis part of my graph and just select the x distance. There we go. Now it takes away the vertical or the y values, and I just have a plot of the x horizontal direction. Make sure you don't have any leveling out right here on your graph. If you do, that means you clicked on it after the person stopped the car. And make sure you remove that or start over. Hopefully you don't have to start over. So now I'm going to select the curve fit button, or the function button right up here at the top. Brings up this screen. And I'm going to tell it that it is quadratic. It already has that selected. Make sure you get the quadratic one. I'm going to select try fit. Good. I didn't get any errors or anything down here on my status. If I did, then I just need to click on the graph, or make sure I reselect the x-axis only. No errors. I got some numbers over here on the A, B, and C. So now I hit OK, and it puts my values right here on the graph. Now I'm going to size my graph down, so I grab a corner of it and make it pretty small. Not really small, but a lot smaller than it was. And put this right about there in the middle. That way, when you put this into your document, your numbers right here will be really large, even though the graph is smaller, and that way you can read them much easier when it's in your document. And that way I can read them too when I look at your document. I'm actually going to make this just a little smaller. There we go. Now, in order to put this in the document, this is the method I think is the best, even though you have to use the Paint program in between. I'm going to hit print screen right now. I hit the print screen button on my keyboard, and then I go over to Paint, and I hit paste. I already had one there a moment ago that I'd already tried to do, but this one just replaced it with the one I did now. So I hit paste once I'm in Paint, and I'm going to select the box selection tool and just select the graph, selecting the graph from corner to corner. Right click on it, copy, and then go over to Word. In Word I have my lab documents ready for the graph, and I paste it, or you can just hit Control and V, and there's your graph now inserted into your lab document, and it has the A, B, and C values right there. So I'll size it down just a little bit, but what's nice is it's still big enough that I can easily read these numbers. So now I can start putting, also select type fit right here. That way you can actually type words over here on the right hand side. So you should have car mass equals whatever that's whatever that was, hanger mass equals, and total mass equals. Now you should have the acceleration from the acceleration that you got from the graph, and that's this A value multiplied by 2. So 2 times the A value is 0.1507, and 2 times 0.1507 is 0.3014. Now you should have your predicted acceleration. And you get that because you know the mass of the hanger, the mass of the car, and the total mass. If you remember from class, hope you have this written down. It's the mass of the hanger multiplied by 9.81 divided by the total mass gives the acceleration. Now, I wrote that down a couple times in class, so hopefully you have that in your notes. And then you should have a percent difference. between the acceleration you got from the graph and the predicted acceleration. Okay, now once you do that for all your trials, then you'll go to Excel, and I already have an Excel document saved and ready, so it should be right. Good. Okay, so then you'll make a table in Excel that has trial, whichever, trial 1, 2, 3, 4, 5, 6, 7, 8, mass on a hanger, however much that was, and the acceleration that you got from the graph, not what you calculated, but from the graph. I will make sure those are from the graph, and put those into a table, and then select these two columns. Now, since on mine I've only got a total of 5 trials, so I'm going to select those. You will have hopefully these 7, but preferably you'll have 8 trials on yours. And then I'm going to go up to Insert, and I want a chart. I'm going to get this one with the dots right there. It's called a scatter plot. And don't get the ones that have the lines or the curvy things or the little straight lines or anything like that. Make sure you get the one that is just dots. Dots only. Not bubbles. Dots. So I select the one with the dots. I make my graph a little bigger. And then I click on one of the dots. And I hit Add Trend Line. Now this should be a linear graph. Remember from class I told you guys why this one's linear, because it's supposed to be representing y equals mx plus b, where the y value, the slope is equal to the little g divided by total mass. So I select linear, and I go down to display equation on the chart, and display the r squared value, and then I am done with this. I exit out of there. And now I've got the equation and the r squared value, and I put my cursor on there, and you can increase the font by holding down Control, Shift, and the little right hand arrow thing. I don't know what to call it. It's not the actual arrow thing. It's like the greater than sign. Control, Shift, greater than sign, and it gets much larger, and you can make it bold. I think you can also just go over here to Home, and just select a font size, so 32, 28, whatever, 28's fine, as long as it's a pretty good sized number. That way it's really easy to see once you put this into your Word document. Also, you go over here when you're on Insert, where is it? Somehow you need to put on your titles as well. And it was here. There it is. When you go to Design, click on Add Chart Element, Axis Titles, the horizontal. What would you put on the horizontal? This one should be your mass on a hanger, and you can kind of tell by looking at the numbers. The first one is 3, then 13, 23, 33, 43. So I should see things that correspond with that. So I'm at 3, 13, 23, 33, 43. So this should be your mass. And then I'm going to add also a vertical one. So I click in there. This one should be the acceleration. And you can have a chart title too if you want. That would be acceleration versus hanger mass. Very good. Now I need to put both of these in my Word document, so I select the table, copy, I go to the Word document, And this will be what I do at the very end after I've done all my trials. Make sure each trial is represented in your Word document. So I insert that table into my Word document, and then I go back to Excel and I grab the chart, copy, and didn't work. There we go. There we go. So now I've got the table and the chart in my Word document, and I can put in here things such as what the total acceleration is from all my trials, and also the my error analysis and stuff like that. And so in order to do the how can I show you that? In order to do the there we go. In order to do that, I'll show you that right here. So we know that when we have y, oh man, this looks terrible. So we know that y equals mx plus b, and we also know that on ours we had acceleration equals the mass on the hanger There we go. We know that the acceleration is also the hanger mass multiplied by 9.81. Well, the hanger mass is the only thing that changed. 9.81 did not change, and the total mass did not change. Therefore, we can say that our slope, slope, is equal to 9.881 divided by the total mass. The reason I know that is because the hanger mass is the x-axis value, and the acceleration is the vertical axis value on the Excel graph. Therefore, the slope of that graph is equal to 9.81 divided by total mass. And if I go back over here, we can see that the slope is 0.0097. So I can say 0.0097 is equal to 9.81 divided by total mass. Therefore, whatever your slope value you get right here, this number right here multiplied by the total mass of your that you had in your experiment should be equal to 9.81. And then you'll do a percent difference between that. So then I'll have percent difference and that's about it. Then you'll do an error analysis on why you think those numbers aren't exactly the same, or why they're pretty close, or maybe way off. If you have any questions on that, you can certainly ask me questions on Monday. This isn't due until Wednesday. Okay, you guys, if you have any questions, if you have any questions, ask me. Feel free to email me. Good luck getting your data, and I'll see you Monday. How do I stop this video?